7th graders. Today we're going to be looking at scientific notation. So a few vocab words before we get started. Scientific notation is a way of expressing very large or very small numbers more easily using a power of 10. So for example, instead of writing 35,700, we can rewrite that in scientific notation, which would be 3.57 times 10 to the power of 4. Standard form is just the normal or regular way that we write numbers. So the example of that was the 35,700. So scientific notation always involves having a number that is between 1 and 10 multiplied by a power of 10. It's a compact way of writing very large or very small numbers. So for example, we have two parts. This first part needs to have a factor greater than or equal to 1 but less than 10. So it could be 1.23, it could be 3.29, it could be anything as long as it is greater than or equal to 1 and less than 10. The second part is a power of 10 written in exponential notation. So it just needs to have a power. So for example, we could say 10 to the power of 4, or times 10 to the power of 4. So here are the steps. Number 1, we want to move the decimal point to the right of the first non-zero digit. So it could be like 1 point something or 2 point something. Count the number of places you move the decimal point is step number 2. And number 3, find the power of 10. If the original number was between 0 and 1, the exponent is negative. Otherwise, the exponent is positive. So here are a few examples. If we're looking at 18, our decimal is at the very end. We need to move that right behind that 1. So since it is greater than 1, we know our exponent is going to be positive. So we have 1.8, that's the first part, times 10 to the power of 1. Now, since it's to the power of 1, we don't need to write that exponent. But just to show you what it looks like, this would be what we would have. B, we have 205,000. So now, once again, our exponent's at the very end. We need to move it over 1, 2, 3, 4, 5 spaces to get it right behind that 2. So now we can rewrite it as 2.05 times 10 to the power of 5, since we moved it over 5 spaces. And since our number is greater than 1, we are going to have a positive exponent again. Last example here, we need to move this decimal point over 2 spaces to get it behind that 1. And since we moved it over 2 spaces, we rewrite it in scientific notation as 1.82 times 10 to the power of 2. Once again, it's greater than 1, so our exponent is still positive. And actually, looking at that, it should be 1.829. We don't drop that 9, it's still there. Go ahead and pause the video and try these next examples on your own. Come back and see how you did. All right, D is a tricky one. When we're looking at this, we don't move it over at all. Our decimal is already directly behind that 8. So if we're going to rewrite it in scientific notation, we just write it as 8 times 10 to the power of 0. We know that anything to the power of 0 is 1, so that's the reason why in scientific notation we can write it to the power of 0, because 8 times 1 brings us back to that 8, which is just in standard form. This is how we would rewrite it in scientific notation. E, we have to move it over 1, 2, 3, 4, 5 spaces. So we get 9 times 10. And now since our number is less than 1, or it's between 0 and 1, it's going to be a negative 5. For F, once again, we can see that that decimal point is directly behind that 2 already. So we would just rewrite it as we see it. 2.003 times 10 to the power of 0. That is in our scientific notation. G, we just had to move it over 2 places to the right. So we get 1.001 times 10 to the negative second power. That's because our number is between 0 and 1. Last one, H, we just need to move it over 1 space to the right, and we would get 7 times 10 to the negative 1 power, once again, because that number is between 0 and 1. Last part of this video, we are going to change scientific notation to standard form. So to do that, we'll just simply move the decimal point to the right for positive exponent 10, or move the decimal point to the left for a negative exponent 10. And we'll use zeros to fill in the places. So for this first example, we have 2.5 times 10 to the second power. Well, I just need to move it over 2 spaces. And once again, because there's that extra space, we just fill it in with a 0. So we end up with 250. Here with the negative, we're going to move it to the left. So we're going to move it over 1, 2. And once again, we have to fill in that empty space with a 0. So we get 0.031. So A and B, we have a couple quick examples here. This exponent of 4 is telling me to move it over 4 spaces to the right. 1, 2, 3, 4. So when I fill in those zeros, I end up with 64,300. Oops. For B, now I have to move that decimal over 4 places to the left since it's negative. So I'm moving it over 1, 2, 3, 4. And filling in those spaces with zeros. So I add a 0 for each of those empty spaces, and that means I am left with 0.00078. Last set of examples for you to try on your own. Pause the video, come back, and see how you did. All right, go ahead and check your answers. When I'm looking at this first one, C, the 3 is telling me to move my decimal over 3 places to the right, so I'm just left with 2001. For D, the decimal is telling me to move it over 2 places to the left because it's negative, so when I move it over 2 places, I have to fill in with 1, 0. So here is my answer there. And then for E, 6 times 10 to the power of 0 just means 6 times 1, since anything to the power of 0 is 1, and 6 times 1 just gives me 6. Finally, F, the negative 5 tells me move 5 places to the left, 1, 2, 3, 4, 5, meaning I'm filling in with those 4 zeros. So there's my final answer.